Start. We are live. Okay, welcome back, hackers. Tuesday, I was talking about ways to think about and analyze web applications for vulnerabilities. Now I'm going to go into detail about more about the specific vulnerabilities that you can exploit and the ones that will be, assessed on the homework essentially. All right. Yeah, so after today, all of the content covered in here should be enough for you to finish homework 3. And if you have any questions, please show up to office hours earlier rather than later. We put on a lot of office hours throughout the week and no one shows up, which I guess is the standard professor experience anyway, but take a look at them early, and if you have questions, try and get them answered earlier rather than later, preferably. Okay. All right, plan of the day. 3 kind of vectors we're going to be going down. First, I'm talking about authentication and access controls, exactly how they're kind of implemented in web applications and ways to bypass them or what happens if they're not implemented properly. Second type is going to be talking about code injections. Whenever user input gets passed to a web application, you shouldn't trust it. Why? Because they can include code, any types of code, PHP, Python, SQL, all sorts of fun injections that we'll be showing off to demonstrate what are the dangers of code injections. And then finally, there's a lot of, we can cook up our own custom web applications that are vulnerable, but in the real world, people work on web applications and vulnerabilities get found every so once in a while. So, if you have a piece of software that is fairly well used or well known, chances are you may not have to actually go and find or develop your own exploits. You can just go find stuff that other people have published. So, awkward. In the case that you're given something that is known to be vulnerable, how do you find exploits for those instead of having to develop your own? Okay, any questions before we get started? Homework, class, grading, well, I don't know about grading, but anything before we get started. All right, let's roll. Okay, let's talk about authentication and access control. So, 2 days ago, we talked about how do browsers and web applications keep track of sessions. When you logged in, how can you tell if you're logged in or logged out? And we explored this kind of challenge that had the danger of, if you remember, they stored the login session information as a cookie and, username, password, admin. If you just modify the cookie on your own browser, it would grant you admin powers, which should say something about, if you're storing, quote, session information as a cookie, you should make sure that people shouldn't be able to tamper with it, or you should try something else. By the way, does anyone not 100% clear when I say session? By the way, session. Sure. Session as in like when you're logged in, I guess.
Is it like the time you're
not just the time, but just like all the details, just like tracking the state and all the relevant information about when you're logged in versus logged out.
Okay.
So I guess like for this, it's like, oh, when I log in, it generates a cookie to tell that I am logged in as a user Joe. Password's probably not a good idea.
From the time you enter till the time you left.
Yeah, just all the data about you while you're quote logged in. So, as maybe aspiring web developers, 2 ways that we could, quote, keep track of login sessions. One is, what if we just, instead of trusting the user to store cookies on their own, what if we just pass it to a database, right? What if I had, every time I logged in, I executed a database query that said, I am now logged in on Amazon.com, and all the shopping cart items should be stored in this database entry, and, just put it on the server instead of putting it on us to store information about whether we logged in. Which, upsides and downsides, right? Let me pull up like some articles that I was reading, stateful versus stateless. So just definition, stateful means that the server itself keeps track of your connection. Stateless means the server doesn't keep track of things. So, I mean, there's plenty of, pros and cons as a design decision, but most of the time it's going to be, if you need to have a database, keep track of if you're logged in or not, it's kind of extra overhead. It's maybe a little harder to scale if you're trying to build like an application that has a million jillion users. And, if you have a trillion database connections at once, it's a little hard for that to manage. Versus something like stateless would say, what if we just store something on the user's computer? But what if we store something more securely? If the problem is just if you store something on the user's computer more securely, you wouldn't have to worry about, am I logged in or not? What if the user tries tampering with that stored data? So core of the design argument is if we're able to implement application, if we want to use stateless session management, which means to store a cookie, we need a way to encrypt the cookie that if you pass the cookie back to the server, it can decode it. And I guess, I don't know if you want the user reading the cookie, but it should be readable by someone. You should be able to decode it, but you also don't want certain people decoding it without certain permissions. Does that kind of make sense? Cryptography and whatnot. So introducing our, I guess, modern day best friend for stateless authentication, it's called JSON Web Token, JWT. It's a 3-part chunk of data that includes pretty much everything you need to encrypt the cookie and check if it's done correctly. So what it does is has a header. It defines that, hey, this is a JWT, and I use this algorithm to encrypt it. You can use, different algorithms to encrypt it. You include the payload in plain text to say, I am encrypting this information. And then in order to prevent the user from, quote, tampering with it, what you do is you take the header and the payload, you combine it, and then you hash it with an algorithm. I guess we'll talk about hashing algorithms at some point. But what it does is just encodes this data in a format that you cannot unencrypt it, and then they use a algorithm to sign it and say, hi, this data has this signature, and if you try and change the payload, the signature won't verify properly, and you know that there's some tampering. On the other hand, if header and payload haven't been changed, you run the algorithm, you check the signature, and you say, this hasn't been tampered with, we're all good. So, I mean, we can take a look at what JWTs exactly look like. So, all of this chunk of data will get stored in your browser as like a cookie, and when you decode it, I believe this is all base 64. It's just this JSON encrypted as a base 64, and then afterwards they go through, run it through a hash algorithm, encrypt it with some kind of secret, and then that's how you verify that it hasn't been tampered with. So, I mean, I can just make one right now. Give an algorithm, JWT. Do you want to make this user? Can everyone see this properly, or do you want to zoom? Actually, let's zoom in. The color theming might be a little janky, but give me a name. Max. All right, Max. Admin, let's say false. Any other funny properties we want to throw in? Just throw something out. I'm creatively bankrupt. Gemini, give me an idea. No, I'm just kidding. I'll just run with what it is. And sign it with a secret. I'll just Control C. So I have an encoded JWT, and let me just paste it and decode it. And it has all that information. Now, if I were to say, I didn't know the secret, just like ASDF, just like some random data here, and I wanted to, because I am very malicious, I want to code. See, how do I want to change this? If I were to just randomly change the data, like from Max to say Jason, but I didn't have the same secret value used to generate the signature. The signature would be different than if I had, you know, the original secret, which was a secret at least. You saw it. You understand it. You probably
Just hit Control C.
yeah, Control C. I mean
Control Z.
Control Z. A secret at least 256 bits long, whatever. The secret is passed into the function. It'll generate, if you have a different secret, it'll generate different output. And because the outputs don't match, it'll fail to verify. Bit of a rambling explanation, but does this kind of make sense to everyone? If you have the data and then the signature verifies the data hasn't been changed, if you don't have the secret, you can't make it signed properly, and then you know that it's invalid. Kind of give me a temperature check. All right.
Go to the encoder and change the data, and then it should show.
Encoder and change the data.
And change max to Jason.
Sure. Jason. I guess I can just grab like a.
But that's something that
A secret at least 256 bits long. Okay. I guess I'll just like use it. Diff check. Bruh. Then what if I use like a different key?
Suppose you don't know the key.
Suppose you don't know the key and just putting in random stuff. There's a difference in the signature portion. All right. Go ahead.
Is the reason why you need like the 256-bit key to enforce it?
Yeah, preferably, you know, the longer the key, the harder it is to brute force it. The key is kind of the main thing keeping it secure. If you're able to get the key, well, you know, that's you're toast. But because you don't have the key and it's theoretically very hard to try and brute force it, it's hard for you to like spoof your own JWT tokens. Kind of make sense?
So the first part, like the JWT token, is like readable by anybody.
Yeah.
The second part is like the part you actually have to figure out to like get the right signature.
Yeah. The third part is just the first and second parts. You hash it and then you run it through that hash through an encryption algorithm that in a way that you can verify that it's correct and also guarantee that it hasn't been touched as long as you have the right key. Cryptography is Ethan's strength, so hope that's good enough. All right. JWT. So, given that we have this kind of format that most cookies are built out of, how do you compromise a JWT? Because, I mean, they're pretty good, but they're not invincible. Cue title screen. They're not there are, if you don't use them properly, they can be vulnerable. So, two kind of main ways that they can be compromised. One is just they're not checked properly. So remember in this header, you can specify an algorithm type. This HS256 is not the only algorithm type. You can actually say like, oh, no algorithm. I think there's like variants of RSA that can be used. I think they give all the algorithms here, like 256, 384, 512. Here's some like RSA variants or whatnot. But that kind of algorithm field is how, you know, the web server is going to be like, let's verify it. Let me look at which algorithm they use and then use that algorithm to check if the signature is valid. If you have your web server in a way that's set up that says, oh, what if I just set the algorithm to none? Make it don't check. You have a problem because you can just spoof them. Alternatively, it's not, maybe you say, oh, I have to use RSA algorithm, but what if they just don't check the signature? So let me just walk through, I guess, this first challenge that worked through this first JWT challenge. Okay. It's on Pico CTF. It's called JOF. It's also linked in the slide, so if you'd like to follow along. JWT should always, okay, just run through it real quick. You have a bank account. Log in as test with test123 exclamation mark. Logged into testing page. Nothing to see here. Okay. Storage, and you can see that we have a token. And if I copy paste this into the JWT visualizer, you can see that have encoded JWT. It stores auth, agent, role, and just all the information, and it's encrypted with secret that I can't really get at. Okay. So, question is, what happens if I just change this JWT algorithm to none? None. And I just put it back as a token, because remember, this is a quote stateless, which means only thing telling the server that I am logged in as this user is just this cookie. The server is not storing any information about the user logged in, and they should be logged in for this long, and if anything happens outside of this time, log them out, or it shouldn't work. Just trusting this token. Sorry, let me just paste it and refresh. Oh, none admin. Almost forgot. I want to log in as admin, and there's no signature verification that I haven't tampered with it. Boom. Yeah, there we go. You've logged in as admin. That's pretty much the same level of defense as just saying, give me a cookie, admin logged in, true, false. Pretty much the same idea, but a bit fancier. Okay. Everyone understand how that attack worked? If you want to go mess around with JWTs, you can just pull up a website like jwt.io, or you could just like Google, I don't know, JWT viewer, whatnot, and then there'll be plenty of online tools that you can mess around. And the attack just set the algorithm to none. Okay. So let's say they got smart. What if they say, don't accept arbitrary algorithms, you have to sign it, and whatnot. Okay, let's try the second challenge. Java code analysis. Have a online book reading service, and we should read the flag book. Okay, let's look at the website. I think this might take a while to boot. So in the meantime, I'm going to look at the source code. Give me this one. Source code. I really want to know, how are they handling the JSON web token? So I'm just gonna select a lot of folders here, but I'm just gonna say, what if I search for the string JWT? Is there anything that's worth reading? Open with VS Code. Okay, wow, importing a lot of libraries, classes, admin, returns JWT if success. So, okay, so a JWT is used to log in properly. Okay, fine. Reauthentication filter. I mean, I trust the user input here. They'll never be evil, or will they? So if I just look, what the comment's implying, if I just put in a random JWT, they won't say like, oh, there's been a change. No, they'll just be like, okay, just accept it as it is. Okay. Just like a definition. Okay. JWT, require algorithm, verify. Okay, so that sounds pretty cookie cutter. See if this loads. Okay, and log in with username, user, and user. Okay, login successful. See what kind of stuff I received. I received, I think this is the stuff from the last challenge, so I will delete these. Sometimes, so I guess a heads up for challenges, sometimes the cookies aren't stored in the very helpful cookie stabs. They're stored in an area called local storage, but it's pretty much just a cookie. Okay, what is this? Token payload. Looks like roll free, bookshelf, expired. This looks like JWT. This looks like the data that is readable by me in the JWT. So let me put this into the decoder, see what it tells me. Okay, JWT, there's an algorithm, and okay, this is the data that is I need. Okay, fair.
Just check OBS.
OBS.
Because of the glitch.
I think it is. Okay. So having access to the source code is pretty powerful because now I'm gonna ask the question. Maybe like I might not be able to use not none as this. Is there any way to spoof cookies? Is there any way I can figure out what the secret is and use it to, find the secret in the source code? Because, they have to be pulling that data from somewhere. So, I mean, Google search secret. Ah, interesting. I'm gonna just look at these two, but this looks the most promising. Secret key. Okay, they're using algorithm. I assume like it takes in the secret key and uses it to generate the JWT. Where's the secret coming from? Okay, what is this? Get secret is just read file, secret file name. I feel like this is it. String, generate random string, not so random, return 1, 2, 3, 4. Does that mean that's a secret? 1, 2, 3, 4. Oh, okay. Okay, so that's a really big issue. The secret, normally it's supposed to be, best practices, maybe some random jumbled generated 256 bytes or 256 bits or more random string. They chose to just use something like 1, 2, 3, 4. Okay, it's valid. I can sign it, which means if I have the secret, I can generate my own JWTs. So can I log in as okay, source code, I'm supposed to read the flag book. Okay, how do I read the flag book? I have to have the admin role to access this special book. I don't know. I guess I'll look at the source code and see if they have an admin user in like anywhere. This looks pretty interesting. Just gonna open all of these and just leaf through them. JWT, secret generator, bookshelf. Interesting. Bookshelf. Initialize an admin and a user. Set profile user admin equals new user. Set role to admin. The full name is admin for capital A. I don't have the password, but because I'm able to just generate JWTs, I won't need it. Admin. The email is admin. Let me look at what the fields of the JWT are. Email. Okay, I have that. Lowercase admin. Min role. What are the different roles you can have? Role. Maybe not here. What is it? Role. Free. Okay. Maybe the role name is admin. So let me just do like admin. Go back. I know if you hold Control click, it will. Okay, I'll just speed run it in the interest of time. The role is just, I think it's just also called admin. Note that the tokens they store is not. You know what? We'll find out. User admin ID. Also, when they created looks like user ID, plain old user is the first user created. Looks like this is also code to create another user. So I assume that maybe the user ID of admin is probably 2. And then what I'll do is I'll look at this claim, this token payload, change the payload, and And I also want to copy the token to say like, yes, this is a very legitimate, I have the token to back up this payload that I am claiming to do. Admin, you need to have admin role to access this special book. So maybe it might be capital A admin. Role capital A admin, and update the cookie to reflect that. Capital A. And get the JWT in. Boom. Okay, let's refresh. Oh, there we go. We can access the book. And remember, the implementation is fairly secure, except for the fact where they had the secret that was literally the only thing encoding and verifying that the cookie was not spoofed. 1, 2, 3, 4. I say that like, oh, people in real life can't be that dumb. Let me just let's see, JWT common key string word list. Yeah. People just, yeah, I mean, even if, could it be 1, 2, 3, 4? Maybe it's not 1, 2, 3, 4. But what are the chances that someone uses my super secret password, my very long and safe secret key, or any of these very guessable values as ideas for JW tokens? Hopefully not, but it's a valid, you could try it. Okay, and of course, I can't pull it up right now, but here's an interesting implementation. This was written by our old club president, Ashley, as a demo. Essentially, you got to use JWTs to log in or not. But when they do operations, they use this very interesting operation called JWT.decode. Interesting. If we look at the documentation for the library they used, decode, I think JWT.decode. Decode is a function that confusingly means that, oh, I'm going to get the payload without verifying the signature is valid. If you want to use JWTs properly, you have to use JWT.verify. I think the source of confusion is other JWT libraries. They'll use like, oh, decode does do the signature verification, but this specific library, it doesn't. So, it could be developer error as well. So that's how you attack JWTs. Any questions so far?
Why did you find the secret in the
First challenge, well, it's got to be, they're pulling the software is pulling the secret from somewhere. So given that the challenge said, I think it's bookshelf. Hold on. Let me see if I can find the name. Java code analysis. When I started it up, it gave me the source code as like a zip I could download. I already have it downloaded, and in the first one, there was no secret. I think in the hints they give, they could be like, oh, what happens if you just bypass the secret entirely? To say don't do verification, set the JWT algorithm to none. Yeah. Any more questions? Thank you for your question. Any more questions about the whole JWT sheboingery? These two are the main avenues to compromise JWTs. All right. Let's talk about access controls. I think we touched upon this a bit earlier in the week where, if you access something with 0.1, what if we try 0.2, 0.3, whatnot? So that is confusingly, there is a name for this instead of just, try all the options, LMAO. It's called insecure direct object reference. So if you have objects in your web server, like web pages, maybe like, I don't know, shopping cart, user IDs or whatnot, if they're numbered with predictable values, if there's a 1, try 0 or 2 or 3 or whatnot. What happens if you try, actually try doing the other values? So this one, I will use try hack me as a demo. I will be using TryHackMe for other demos throughout the quarter, so I guess I'd recommend you can make an account if you would like to follow along. Start machine. AttackBox is a subscription service, so I will say that I have given money to TryHackMe, so you may not have this option available because AttackBox spins it up directly in the VPN. If you don't have the premium subscription, you just have to download the VPN file and start it on your own computer. But you can still do challenges if you like. In a nutshell, it's just if you have access to, if you create objects in your web application that multiple users might use, you're going to need to put access controls. Before you say, oh, user, I want object 307, you're going to want to put some code saying, hey, does the user actually have permission to look at that object? And in the case that they don't, you get funny results like this. Give it a few minutes to set up. If you want prevention methods, there are very helpful online resources for if you're developing applications, say like, oh, if you want to prevent people from doing this, what if I just guess 0 instead of 1? One way to do it is make, instead of just using 0, 1, 2, 3, you could use identifiers that are more harder to brute force. There's a thing called, let's see, UUID. Like a thing you can use in computers where it just generates a unique ID that is 128 bits long and 128 bits is a little hard to grab a needle out of a haystack if you're using a really complex identifier. Otherwise, make sure you have proper access controls. But see if it loads soon enough. Okay, IP address. If I just loading, preemptively copy the target IP. There we go. So there's a website. I mean, this one, they do a pretty good job of explaining what it exactly is. You have let me do this. Control C, Control V, 10. I'm just going to type it out. 10.145.183.107. It's a fun website, and IDOR, if you log in, Niels, try hack me 2025. By login. So, the question you always ask, where does this information come from? It had to come from a network. What kind of requests did they make to get this information? And it looks like when they loaded information, let's see, vouchers, just expand it a little. All. Okay, shrink this a little. View. If I go to my profile. Oh, no, it's just resize these. Escape. Cancel. First page, see what requests are being made. Vouchers / I think there is a way to be like, oh, I'm currently logged in. Let's see. See a dashboard like this. Use developer tools, inspect, network. First a page. Is this just not large enough? View account. Oh, there we go. View account info. User ID equals 10. So given that user ID is 10, how many users do you think we think exist at the very least? All right, what's the next number we should try?
0.
All right, let's try. I'll try 9 and then 0. All it's doing is just doing a GET request to this given the variable user ID equals 10. So, I mean, if there's no software on the back end saying, oh, let's do a permission check before we say like, oh, is the user ID actually 9? Let us do a, happens if I change this to user ID equals 9. For one, gave an unauthorized. Storage, there we go. In storage, local storage, user ID 10, storing this data, I'm logged in as user ID 10, and then I guess it's using this information to say, oh, let me do a GET request to the backend to get all the information for user ID 10. So let's try 9. Refresh. I don't know. I don't know if it's large enough to view on the screen, but that is definitely not the ID number we had before. Instead of 9, let's go back to 9, back to 10. We're now doing an eyeglasses exam. Back to 9. Definitely this is data that we probably do not have access to. Okay, different ID number. Data we probably shouldn't be looking at. And then back to 0. Looks like they don't have something for, wait, is this, screen looks different. Is this no, it looks like maybe they don't have a user 0. Doesn't matter. The moral of the story is if they tell you that there's 10 users, you should at least try and see if you can access users 9 through 0, because, you know, what are the odds that they don't put proper access controls? Okay, that's IDOR. So I guess to the third type of exploit, you have a login screen. Maybe, you know, you can't do cookie shaboingery anymore because you're not logged in, and you have to, you know, you're just stuck with a username and a password, and you just have to get in. Maybe you've tried default credentials, just try like a username password. You don't have a lot of luck with that. What do you do? So we got to remember, how does a login exactly work? When you log in, you send information to the server, and the server has to maybe look in a database somewhere. Does this username exist? Does this password exist? We're looking at a database. You have to run a query against a database using some kind of structured language. Structured language database. Structured query language. Yeah, this is our best friend SQL. So before we talk about SQL injections, any questions about all the authentication shaboingering we have just done? Cool. All right. Let's talk about code injections. So, I mean, you probably have a good idea of what code or command injection is. You know, you might have heard the phrase like SQL injection thrown around. You have an idea of what it is, but let's define it using very strict terms, you know, a strict mathematical definition. I don't know. Suppose you have I guess this is modeled after SQL. Suppose you have a factory robot that accepts instructions, you know, fetch an item number from a location, from another location, and do things. And normally, you know, if you operate it normally, you just say like fetch an item number from location, and do things. But there's a lot of trust going on. What if I put more instructions inside those parameters where, you know, normally you accept like numbers and text, but if I just put more stuff in? Suppose an attacker says, you know, fetch this item from the section, from this rack, throw it out the window, and then ignore the other instructions. This very, very extremely strict definition of a command injection is, you know, these are the principles by which SQL injection and other similar types of injection operate. You have some kind of user input. An attacker says, oh, what if I put funny code instructions inside? Let's say, I don't know, similar to, I guess, earlier last week where we said, oh, you have printf. What if you just fed in format strings into printf? You can do funny things. Same same thing goes for web applications. You have a form. What if you put HTML code in that form? Does it show up on the user screen? What if I have SQL instructions to do a lookup for a login? What if I put more SQL instructions into that user input and see if I can modify the query to do different things? So I guess two kind of goals-ish that you can hit with a SQL injection. SQL, again, is a database. It stores information that other people might want to use. So first thing is, if your SQL injection probably has sensitive data, less sensitive data, what if you can manipulate queries that normally look up less sensitive data to make it look at more sensitive data? Alternatively, there's password logins. What if I just modify, that the password, your username and password are going to go into that SQL query? What if I modify the SQL query to say, instead of looking up the user, make it return a statement that always returns true? So the authentication always works even if I don't have the right password.
How did a query or string be interpreted as code input?
Oh, it's very simple. I don't know, give me a SQL query. Okay. This is what a SQL query looks like. Code is text, text is code. If you insert text and it's interpreted as code, it's code. Does that kind of answer the question a little? It's not like, I don't have to insert assembly instructions into SQL because SQL just operates on text. If I just tell it select something else, more SQL instructions, ignore everything at the end, you pretty much just run your own SQL.
So they combine instruction and data memory into one big memory?
Yeah, it's just, if you want to think of it as string concatenation, all it does is it takes your user input, concatenates it into the query, and then it runs the whole thing. That is how simple SQL queries work. So let's work through some basic challenges. Here's a reference for simple payloads, but we'll just walk through this first one. Start. Let's see. All right. Start instance.
Multiple SQL languages?
Multiple SQL languages. Actually, they're mostly similar, but slightly different. I would say most of them, they're pretty much all the same with maybe small syntactic differences. Like select statements always going to be there. From statements always going to be there. I'd want to say oh, it's the same relation as C has to C++, but I don't know. Does anyone know any programming languages that have similar syntax to each other with minor differences? I don't want to say Python 3 and Python 3.1, but
Java is kind of similar to C++ in a way, but the object-oriented.
Yeah, you say just object-oriented.
So you have to kind of guess what SQL language they're running on?
Yeah, sometimes, you can use automated tools to speed that up, but they're mostly the same, right? A select statement will always be a select statement. No one's going to be like, I'm going to, replace my custom SQL language is actually going to use SLCT instead of the full select keyword. All right. Let's try testing login. Login failed. And this challenge has done a very nice thing for us. It shows us what the SQL query is that it's using to do the challenge. Okay. Well, the first thing first, you can probably see that variables in SQL are delineated. I don't remember the word. They're wrapped with single quotes. So an easy way to check if something is vulnerable to SQL injection is to put a single quote in a field, and if it explodes. So see, they didn't do login failed. I guess there's a syntax error and the query was unable to complete, and you see the query 3 quotes with nothing inside. You can probably inject some funny things into SQL. So let's see. So how do I make it ignore the rest of the query? Well, comments in SQL use double dash. So I can say Name equals test. I don't know if I can
No, I need to like type in the bar.
type in the bar. Well, actually, what if I just do this? So what I want to do is maybe test, end the quote, and then ignore everything that comes after test. Okay, login failed. I don't know if I can, let's see, like SQL syntax highlighter. Oh, SQL. Okay, spoilers. If you go and find the ECS198F lecture repo, I pushed some updates to it, and I believe I cooked up with Claude a tool to like visualize SQL's injections. So host 3000 raw query select. Think you can do injection parameters? No. I want to do say like admin. See what is different. Select from users where. Select from users where. Okay, this is. Let me just zoom in a bit. This is run with Docker. So if you clone the repo and just go in there, you get Docker, you run Docker Compose up, you'll be able to get it. Let me just say, I want to end quotes and then ignore it. If you can, the syntax highlight. Ooh, the lighting is not great, but you can see that the entire and password equals part of the query got commented out. I put a, in the admin field, all I did was just admin. Let me put a backtick and 2 gappers. Well, in SQL syntax, it just happened to be end variable and then comment out the rest of the text. So I have now created a query that's very much shorter. But problem is there's still, what if there's no user called admin? Does this return true? Well, actually, let me see if I can just do something similar. Admin, and it really doesn't matter what I put into password here. So back, I don't know, Mogus, admin. Oh, okay. So did it happen to be an admin user? And because normal query, it had 2 parts. It's an and statement. You have to have the user and the password for the query to pass. But in this case, I just commented out the part of the password. I don't care. I don't need a password. Is there a user called admin in the database? Well, it turns out there was. Logged in. Can you see the flag? It is in plain sight. Source code.
How would you find the user if you don't know that it was an admin mistake to begin with?
I mean, admins tend to be named admin. You can try guessing, or you can use other techniques I'll talk about just in a minute to try and leak other databases inside the query itself.
Yeah, okay. I mean, like, this is basically based off of a hunch, but like, how do you actually do it without the hunch?
Do it without the what?
The hunch, like, you had it might be called admin, but like, you don't know what it'd be called in any other account.
I mean, half of pen testing is just trying things and failing. So, I mean, you could try admin, you can try root. If they don't work, such is life.
You like print out usernames? Is that what you can do?
Print out usernames? Yeah, sure. I think I will use the next challenge I'll talk about. Literally covers not just like bypassing admin, but also how to leak data. All right. Let me spin up this instance. I'll need the write-up for reference. So, I mean, okay, let's try admin. Well, let's just try the funny trick we did. Just find things with admin and comment out the end. Test. Oh, okay, they did a funny trick. They put the username at the end, so I just commented out nothing. And okay, well, anyone got a solution?
You just swapped it too, right?
Yeah, exactly. Put the injection in the password instead of the username. I don't know. This doesn't matter. Like password equals. I mean, let's see. Well, we got a problem. Well, actually, I don't need that. I don't think I need that first nest. So, I'm just gonna put like bogus. Let's see, test. Comment out. Okay, login failed. So helpful data. I've now constructed a valid query. It's no longer exploding. I have a query. There's no password name text. Well, here's another funny trick. You can use conditionals, right? We saw and was a valid thing to do. What if I use or? What if I just said find return true if you can find a user whose password is test, or true? What's the result of that query?
True.
Exactly. Anything or true is true. So if I just do let's see, bogus test colon space capital or 1 equals 1 and then comment. I don't know if I can copy paste. Oh, I can't. So I don't know if I can draw up a big notepad, but I'll type it here and copy it. So let's see. Random password, end the quote, add an or statement, and then here's true, and then comment out everything afterwards because we don't care about the admin part. Control C, Control V, test. Oh, logged in. SQL query return true or true, and we got true. Okay, it's pretty good. Now we have, it looks like we have a database that's returning data about some is looking up some table. Let me just see if I can. Oh, no data. Star. 1, 2. What's going on?
City.
I had city names. I forgot what the city names are. That's kind of awkward. But here's what we have. We have this search bar is definitely running some kind of SQL query, and you have a table that I guess is taking 3 results that I can read. So what if I just modified the query to read something that what if I had to read some other data? The data looks like, oh, select from, what if I included my own select from? Okay. See if okay. So there's another trick in SQL injection called union select. Because I have 3 columns, this table is expecting whatever I look up in the SQL query will have 3 columns. If I give it something with 2 columns, it's going to error out, say, hey, I don't have enough data. Sucks to be you. So you can pad it. What you kind of have to do with these table attacks is you have to pad out your query, say, oh, I'm only looking for one thing. So for these other columns, I'm just going to insert like 1 or like true or some other random data instead. So, okay, I'm reading from the solution here. So I'm going to say union select. I want to select, let's say I just want less values. Name from, and because this database is SQLite, you could do some discovery tactics to try and figure out what version this database is running, but in the interest of time, I'm just going to speed run it. Master stir end query solon. What? Hold up. Give me a second. Select from 1, 2, 3. 1 union select 1 select version colon 3. Oh, yeah, that's what happened. To return no data because I didn't have enough. Info in there. So union select 1. If I just say like this has 3 tables, but I only give it 2 tables, it's not going to return any data. But if I say 1, 3, so 1 value, 2 values, 3 values. Oh, yeah, it executed the command. I ask for the first column, insert value 1, for the third column, insert value 3, and for second one, give me the version of the SQL database. And turns out it's running SQLite 3.31.1. Let's see, so let's try and get some more information about this. And select name SQL null from SQLite master. What I'm doing is every database will have, you know, a database, a metadata database. What is, I need a database of what tables are in my database. What, I don't know, maybe like what data types are in my database. There will always be information about the database in the database. So if you're able to write a query to grab that information,
Think about how like a Google Sheet spreadsheet can have multiple tabs on it, and that the names of those tabs have to be stored somewhere, and so that's stored in another like with data store. Kind of like that. You're trying to get SQL to tell you what's inside of itself.
all right. And it looks like, I know this is a little hard. There's like a lot of information here, but it looks like there is a table called hints that has, well, this is just like reading the data of what it looks like, right? But hints, it has an integer, not null, called ID, and it has a table, and in that table is info. Okay, there's also users, and very interesting, there's a table called flag. Just in the interest of just like reading the hints, I'm just curious what happens if I do, I think from table, if I read hints, I want to read the ID, ID info null, and then just to pad it out, if I read the hint, what? Very, very, very helpful hints. You are close now. But I mean, you know, we know the technique. We can use it to read other things. I will say that, let's see, union select. Let's just go back. Oh, name from one, info null. I think no, it was the name SQL null. I want to read more table. See. So from the more table, remove everything at the end. I want to read ID flag, and then just pad it out with null. Sometimes the way that these challenges can be made harder is that these columns have very strict defined data types. Like maybe city is a string, address is a string, phone has to be an integer. And you know, if you try to just throw arbitrary data into the columns, it'll be like, oh, this is not valid. The data types don't match. But in this case, I think they've decided to be generous. But part of the strategy of using this padding union select method to pad out the table is just you can insert the data types into the right place. But in this case, oh, all right. If you're here, you must have seen it, and it looks like we've had a flag. Okay. I realize I didn't explain the SQL, the syntax very well, but I guess there's a W3 Schools SQL syntax. All right. I might not have time to go through this, but this is like a useful tool that Claude made for me. That essentially I have it cook up. Oh, you can use raw queries. You have a live database that you can just like set up and mess around with. It says like, hey, will this query work or not? You can like, here's a sample login field. Can the stuff you put in actually pass the login, and other ways of defending against SQL injection. So the question is, how do you prevent it? You know, SQL injection seems to really rely on the fact that there's special keywords. You know, SQL, you know that it'll have select, you'll have from. I don't think any legitimate user will be inserting SQL and syntax into whatever they're looking up. So what if we just use a block list? What if you just said, I will ban you from using the word select in your variables in all caps because that is SQL syntax and you're not allowed to use it. Or, I don't know, you're banned from using double dash and whatnot. Might not have enough time to cover evasion, but essentially you're playing a cat and mouse game when you decide to, you know, whitelist or blacklist certain phrases. I mean, okay, who here has gone to a high school where they filtered the internet, but you found ways around that internet filter? Yeah, exactly. For every blacklist or whitelist of characters you have, creative minds are always going to find a way around it. I mean, hell, there's a the people who are here to promote web security have an entire worksheet of how to bypass these methods. You know, like if you say, like, for example, if I have a preprocessor that scans your query and deletes the characters dash dash because you're commenting something out, and that is evil SQL injection technique. I've done challenges where, what if I put dash 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 dash? So they delete the first dash dash, but they don't hit the second dash dash because, you know, they just assume find the first match and delete it. Well, what if first match is nice, but what if we had second match?
If you just loop through the whole end instead of dash dashing.
Yeah, you could. I mean, then you're banning like the dash from ever being it. But what if instead of putting dash, I use hexadecimal characters? I use, I don't know, find the hex percent whatever that represents the dash character. What if I use that instead of dash? And, you know, it kind of goes, you know, the cycle goes on and on and on again. But ultimately, the issue is when you build a SQL query and you're just doing it quote normally, I guess, you're directly concatenating whatever your user puts into the query. Instead of like saying, look literally for, I guess I'll talk about it. There's the solution to all SQL, I guess most SQL injection attacks, I don't know if there's like some weird edge cases, is something called parameterized queries. So instead of like doing let me directly feed whatever the user put into the queries, you use, let me see if I can find a MySQL. Okay, just parameterized queries, MySQL. Parameterized. So instead of putting like literal variables in, you can use something, you know what, I'm just gonna find an image because I don't like these. This, I don't like this. SQL injection. Essentially, instead of you're telling the query will be handled, instead of directly putting the user input into the query, it'll say, hi, here's a placeholder. This placeholder will need to be, you need to look in the column users for this. And instead of like say, put whatever the user put into the query, it says, look. So say if I wanted to look up the username admin quote dash dash, instead of feeding that directly into the query, the parameterized query will be, I will literally look for a user that matches the name admin quote dash dash, as opposed to, you know, building it into the query. It'll treat it as a variable and it will look exclusively as a variable instead of just, I don't know, doing whatever it was doing before. This is the hands down, like if you have a problem with SQL injection, parameterized queries is what everyone advises as a solution. In fact, here's a cheat sheet. Here's a SQL injection attack. Ooh. What you do? Let's see. Instead of strongly discourage escaping all user, let's see, allow list input validation, stored procedures, parameterized queries, and then don't allow people to use custom queries you use. There's a way to define it. I will refer you to this because I'm not a web developer. All right. SQL injections. Other ways of doing injections, not just SQL. There's stuff like, let's see. Let's run through these. Cross-site scripting is where I was describing earlier. You can inject random HTML code into like a form. What happens if a user browser renders that HTML? And you say, oh, it's just HTML. Oh, you'll be able to print extra funny things. Oh no, let me execute this one. This is a hard challenge. I will not run through the entire scenario, but let me just spin it up and show what's going on. I have a nice web app that allows you to take notes. Register, test. Create a new note, and I just say like, test. Okay, excellent. It renders it. What if I did something like test colon? I think this is a tag. Added text. Ooh. Create. Oh, look, it followed the HTML tags and actually rendered it. Well, you know, HTML tag rendering is not the worst thing in the world. I mean, the entire 90s was built off of people writing HTML code into their websites. But what if I was to use something like write a little JavaScript pop-up that forces you to do a pop-up? So I think it's alert test. Let me see if I remember the syntax for this. See, cross-site scripting alert. Okay, I'll just use this. Insert a tag. This is a bit of JavaScript code and force it to generate an alert. Focus. Okay. And now every time I load the page, it will run a bit of JavaScript code that will make me do a pop-up. Oh, wow, how scary. It's going to do a pop-up. What's the big deal about running JavaScript code? You see, but, the whole deal with browsers that render HTML and run JavaScript code, what can you do with it? Well, just run through this attack. What this attack is, they used this ability to inject arbitrary JavaScript code. There was like a admin bot that was automatically navigating to the web page. They would use that piece of stored code to steal that admin's cookies and retrieve a flag. I guess the operation is similar to, anyone here heard of IP grabbers? IP grabbers, I guess I'll just like explain briefly how they work. You have a link, you send someone a link, and then what it does is it forwards their traffic to like that IP grabber server, and then to the end. So if I have an IP grabber link that goes to google.com, when I click the link, it'll go to the IP grabber server, and then go to google.com. But in that time, it's read my IP. Similar kind of concept with cross-site scripting. I have a bit of JavaScript code. I can write a JavaScript code to read your browser, grab your cookie, and then that code will send that cookie to an external server that I control. And now I have your cookies. We're looking at JWT store sessions. I could, pretend to be someone with a stolen cookie, whatnot. I don't think cross-site scripting will be on I don't think it's part of the assignment, but understand that this is allowing people to run random JavaScript and HTML code in your website is an issue. Second one is directory traversal. This is a very funny one. I'm just going to shut this down. Go to challenge. Okay, can you get the flag? We know the website files. So, website files, web pages, they're just HTML files that sit on someone's computer. But if you're able to, I don't know, force the web page to render something that's somewhere else on the computer, maybe you can do that. Flag is at flag.txt. The website is filtering absolute file path. So it looks like it's just reading stuff. If I say divine comedy.txt, okay, it's read the entire divine comedy. If I go up, a directory injection is just say like, oh, well, start with the stuff that doesn't work. Flag is at flag.txt. Can I get it to just read flag.txt? /flag.txt. Not authorized. Okay, that is cringe. What's another way to specify file paths? ... If I did this. We know that there's a flag.txt somewhere. So I think this is enough directories. And now, because I've inserted file path in, I can use it to read. This is it's not just being able to read files, but sometimes on like insecure web servers, you'll be able to be like, oh, navigate me to ... and it'll actually show the entire directory listing of all, you run ls through your web browser because the web server had that option enabled. Okay, and then arbitrary file injection or execution. If I handed you a piece of code and just run it, trust me, bro, you'd probably say no. Same thing operates with websites. You shouldn't trust random pieces of code that people give you, but it might be an issue. So let's walk through this tri-hacking mix. Box, Kingdom, shut this down, start this up. Okay, I realized I've just blown through a lot of topics without asking for questions. So any questions about all of these? SQL, and whatnot. Any questions? Give me a temperature check. Oh,
Like with the SQ26, like if you don't have like access to the actual like SQL code that's being run, like how do you kind of like figure out what kind of like characters you need to do?
you guessed. I wasn't. I mean, if you don't, these challenges are nice. They show you the actual SQL queries that are being run. But in the real world, you might have to do something known as a blind SQL injection, which is just you guess that the query looks like this, and then you just start inserting characters and hoping it works.
You can definitely use intuition for it. Like if you can figure out the logic for like what the query is doing, then you can try to construct the query. So you saw the select statements, right? You can try to figure out what the select statement will actually look like, and that'll give you a good idea of what is being injected, and then figure out the syntax for the injection.
Yeah, I mean, let's see. Sleep. Yeah, there's some, in order, some people technique to see if a SQL injection even exists in the first place is, some SQL servers, they support the sleep command. So if you want to figure out if something is vulnerable to SQL injection, sometimes you just throw sleep and see if it lags for 5 seconds. And if it lags for 5 seconds, you might be able to. That's proof that it might be vulnerable, whatnot. And you literally do this when you cannot see the query. You just have to guess its the purpose of it, just like see if it works. Okay. Okay. Let's see. All right. I know. So I was talking on Tuesday about how do you brute force web directories using GoBuster. I'll just like demonstrate that real quick. I have this image. Let's see. GoBuster. Let's see. I need a word list. Oops. Do I have the word list? Okay. Okay. Go Buster. What's the syntax? Go Buster dir. I can share the syntax a bit later, but let's see dir. And I need the URL. So HTTP 10.145.186.15151. And then dash word list, user share. You can just on Kali machines, the word lists are all stored in a similar folder. So all you have to do is just Google. You can either download them yourself, or you can just Google Kali. Where are the word lists? So user share word. I think word list. Give me dirbuster. Oh, this is good. Dirbuster, and then what is there? Directory list 2.3. I'm just gonna use small. Connection refused. What's going on? Oh. Pretend I did an Nmap scan and I found out that the web server is not on port 80 but on port 85. And then now what this is doing is just running a tool trying all these possible directories. Let me see. Like cat user share word list dirbuster what directory list 2.3 small, and this is just a bunch of possible web pages that might be at the endpoint. There's an endpoint called app, so just be around. All right. Any questions about dirbuster and its use? It's like mass what's called enumeration. Just go and try all these possibilities to see what's actually running.
We'll talk about it more next week.
Yeah. Okay. Dirbuster. Okay. Last one that's related to Mushroom Kingdom. I'll speed through. So that specific challenge is running a piece of software called Concrete CMS. And an old version of it actually had a vulnerability, but how do you find that vulnerability? Well, thankfully, someone has gone around saying, hey, if you find a vulnerability in a computer system, tell us. We're going to give it a number so it can be, use a similar name for it, report it. maybe like tell people what exploits exist for it. It's called CVE, Common Vulnerabilities and Exposure. Just if a security bug or vulnerability exists, it's probably going to get a CVE number, and you can just look up, if you have a piece of software that you think might be vulnerable, just look up software space CVEs list. So I mean CVEs list, concrete CMS CVEs list. Version number is much more helpful. I think it's, let's see. I think it's like version 3. CMS. Okay, this one. This is this the one? This is not the one, but it's very similar. Since we're running out of time, I'll just describe the vulnerability, and I guess I'll show it next time for arbitrary code execution. What happened was you could, for that, CMS is just like a way to manage web pages. Think of it like Google Sites, except with more features. What could happen is if you just upload a code file to it, and said, oh, if an admin can say, oh, I can allow these types of files to be uploaded and run. If you just say, oh, this web server uses PHP files. If you upload any PHP code to it and open it, it'll just run it automatically. So what could happen is if you uploaded a certain piece of code on PHP code that says drop into the terminal and open port 4444 and give me terminal access on it, you could pretty much clone the web server by just uploading a funky piece of code to that website. It's 3 o'clock. I want to respect your time, so I'll do the full demonstration sometime next week. But yeah, this should be all you need for assignment 3. If you have any questions on it, please shoot us a message on Discord, come to office hours, whatever. We're available. All right, thanks for coming, everyone. Happy hacking.